My name is Gabi, and I'm delighted to present the Project Doric details, progress, challenges, and future opportunities to you. Firstly, I would give the microphone to Mai from Aberdeen.
Hi, welcome everyone. Good afternoon, and thank you for participating in this webinar this afternoon. I'll just give you a brief introduction on the project. It's Project Doric, and it actually stands for Domestic Optimized Retrofit Innovation Concept. It sounds like a long name for it, but just for those of you who are not very familiar with Scotland, Doric is also a Scottish dialect, and it's spoken up here in the northeast, so it is quite apt that it's called Project Doric and based in Aberdeen. So that's a little known fact I like to throw in there. I just thought to lighten the mood to start with. So domestic optimized retrofit innovation concept actually has significant meaning for each of those words. So it's obviously looking at social housing, which is the portfolio that we're looking at delivering this project. But optimize is using energy reports, for instance, to select the properties we want to carry out the retrofits. And the innovation is what Gabi will be talking about in terms of the solar power technology. And obviously it is a concept because we are trying to scale up the results of this project into a wider portfolio that we've got. So a little bit more about the project. It was developed back in 2020, 2021, but I think everybody remembered that it's during COVID as well. So timing wasn't great for our project to take off in earnest. So we had a bit of delay in actual starting the project. So amongst all that, that will be some of the challenges that's probably going to be mentioned throughout the slides at some point. And the other thing I would like to raise is around the innovation on the consortium-based approach. So we've had different partners coming onto this project, which is public and private sector. So again, Gabi will go through who we are and how we work together. So this is very exciting, and I would love to share this with all of you and how we approach this project. It is about fabric first, so it's about retrofit and about past 2035 and how we, as a council and local authority, have a strategy around past 2035 and understanding the challenges if we were to upscale it to a larger portfolio of properties. The project also includes renewable energy generation as part of our pathways to net zero. So we're looking at PVs, batteries, air source heat pumps, and other decarbonisation options. So that is all included as part of this project as well. Again, valuable lessons learned. And the final thing is around affordability of energy for their tenants as well. So this is very exciting, and I hope this gives you a very good introduction, as best as I can anyways, and for Gabi to take forward now in the following slides to talk through what the innovation and around the technology itself. So over to you, Gabi.
Thank you very much, Mai. So here you can see the topics I'm going to talk about. The first section will be the concept, where I'm going to show the participants, the discovered issues, and the project goals. The next section is about the solar power product. I will give you a high-level summary of the product, installation challenges, installation options. The following topic I touch is on the air source heat pump, theoreticals, benefits, disadvantages, then a couple of examples from the project. Lastly, I touch on the installation challenges. And the last section is the project implementation. Here I am talking about the process of the project status, challenges we found. Finally, I show future opportunities the product and the project could generate. In the next couple of slides, I'm showing the project concept, participant, and project goals. Aberdeen City Council is the client. The council has more than 22,000 social houses aged between brand new and 100 years plus. SMS PLC, we are the principal consultant in the project. Our role is to review and validate the proposed solution, support the client. Robertson is a family-owned construction, infrastructure, and support services business. Robertson is responsible to deliver the work. MRT is the principal architect of the project. They are responsible to provide all architect designs and fabric upgrade requirements to achieve the targeted energy efficiency. IRT is the energy surveyor organization. that carried out the energy surveys in the buildings, made recommendations to improve the property's energy efficiency, and they are responsible to validate the energy measures after the completion. Aberdeen Council found the following problems in their social housing tenants and properties. Maybe a few of you recognize similar problems in your portfolio housing estate. As we know, fuel poverty is a major issue in the domestic sector. The unpredictable energy price rises just amplify this issue. Also, the social housing properties were built more than 50, 60 years ago with lower building fabric insulation requirements according to the current building regs at the time. That's why these buildings have lower energy efficiency and higher heat loss. Following this, higher energy cost and cost for the residents. The higher conventional energy consumption result a higher carbon footprint too. The heating systems have not been really upgraded since they had been installed, and the gas combi boilers were changed if they reached the end of the life or the boilers broke down. Lastly, there was no renewable technology installed yet in these properties. Here you can see the project goals, which could provide a solution to reduce the found problems in the area. As Mai mentioned, a fabric first approach, so upgrade the fabric of the homes, reduce the heat loss and energy consumption, and that's why reduce the energy bills. Install PV arrays on the roof with connected energy storage assets. Replace the conventional gas boilers with heat pump to decarbonize the heating and hot water system. Maximize the self-consumption from the PV battery system, reduce the exported energy from the grid, reduce energy bills, thereby fuel poverty, and lastly, deliver a replicable solution for other possible future projects. In the next topic, I'm showing you the solar power product details, presenting the benefits in one property. Lastly, I am touching on the installation challenges of the technology. Here you can see the basic details and the schematic of the product and how it can be connected to an existing power system. The targeted PV array can be between 3 to 6 kilowatt peak. This PV array provides a sufficient generation throughout the year. In a southern Progen location, the PV array could be smaller based on a higher PV generation. The 5.5 kilowatt battery can store and supply a significant amount of electricity for the residents. Lastly, the heat pump will replace the gas boiler and will be the primary heat source for heating and hot water. The heat pump can use any excess energy from the PV and the battery. On this slide, you can see the benefits of the product, and I present the estimated savings on one of the properties in the project. I listed the main benefits can come with the product. The heating and hot water system will be electrified. Gas supply can be disconnected, no gas standing charge, except if the resident has a gas cooker or other gas consumers. Discounted electricity rate can be charged to the residents via a power purchase agreement. This provides a lower energy supply for the residents and generates some saving. As you see, long asset lifetimes, we expect from this product visible saving for the residents. On the right side of the slide, you can see the summary of 10 Hartfield Place estimated post-install consumption with the installed product, and you can see the resident can achieve £125 energy saving cost and can save another £105 from the gas standing charge. The overall estimated saving is around £230, which is a 14% reduction. The next slide is the installation challenges. The battery has a couple of strict minimal clearance requirements to protect the buildings and the residents in an emergency case of fire. In a typical house, not the easiest to find a suitable location for the battery. which would tick all of the boxes. Some cases, non-combustible barrier need to be used, as you can see this, the red lines. All nearby metal structures must be earth bonded to prevent electric shock if the asset is damaged for some reason. DC power wiring should avoid any internal habitable space to minimize risk of fire or electric shock. Position and sign of firefighter switch. The firefighter service needs a clear indication of the firefighter switch location, and they can disconnect the DC supply immediately on an emergency. The next section is the air source heat pump. In this section, I'm talking about the theoretical heat pump cycle, its benefits and disadvantages, retrofitting existing systems with heat pumps, and I touch a couple of installation challenges regarding with this technology. The science behind it. Everyone has a heat pump at home. We all use the heat pump in our home to keep the food chilled. The energy is extracted from the inside of the fridge. Then the energy is released on the rear grill of the fridge. Oh. The heat pump works on the same cycle, extracts energy from the external air, ground, well, or freshwater sources, and the extracted energy is released into the property. Of course, the heat pumps are much more advanced asset than the fridge freezers, as sophisticated control systems are the soul of the asset. Then the inverter and reverse compressor allow us to control the output based on the demand and optimize the asset efficiency. Here you can see the pros and cons why we choose air source heat pump in the project. The pros: the easy installation, no need significant groundworks, borehole or horizontal collectors. The capital cost is significantly lower than other heat pump technologies. The refrigerant gas can achieve a high flow temperatures alongside the still good efficiency. Couple downsides: lower efficiency in cold conditions. The efficiency depends by the external weather conditions. The fans make noise. The manufacturers work hard to reduce the noise, and with the latest products, they achieved a hearable noise reduction. The capex is higher than a conventional boiler system. The hot water cylinder needs internal space. Typically, the cylinder and pipework takes a space of as a fridge freezer from the house, and the incoming power may need an upgrade to cope with the increased load. The team found 28 properties which suitable to receive the technology. These examples are from the project, the pictures. In most cases, the combi boilers are in a cupboard or a storage room which can accommodate the hot water cylinder. That's why the asset can be placed close to the cylinder and reduce the pipe runs and losses. Yes, in some cases, the heat pump and cylinder are on the opposite side of the property. In this case, the pipes have to run on the most practical and shortest route to minimize the losses. Here you can see the current system schematic in the properties: gas combi boiler, distribution pipework, heat emitter, cold water supply, and hot water supply for the showers and the kitchen. You can see a cutting point, and on the right side of the schematic, we didn't plan any modification in the system except if a radiator needed upgraded. The upgrade was focusing on the left side of the schematic. And here you can see the heat pump connects to a pre-plumbed hot water cylinder, and the hot water cylinder connects to the existing heating system with a minimal disruption. Okay. Here you can see a real example design from the project. The boiler is located on the front of the property, which is in a storeroom. This storeroom is suitable to accommodate the hot water cylinder. That's why the heat pump can be placed just outside of this storeroom, and the interconnection pipe can be really short. And then the new heating and hot water supply can connect to the existing system with a minimal disruption. As you can see, the battery can be placed left side of the door to keep the minimal clearances, and some short cable run to the DB board, and the battery is connected to the power system. Couple installations challenges. The key points with the installation, we need to keep the minimal clearances around the air source heat pump to provide the sufficient airflow. A protection closure may be required to avoid any injury by the moving parts. As I mentioned, the hot water cylinder needs a suitable cupboard or storeroom to position it. And finally, a suitable condensation drainage is required to prevent any potential ice formation. Otherwise, this could happen. This is an extreme ice formation and a potential health and safety risk. In the last section, I talk about the project implementation, project status, and challenges have been discovered. Here you can see the project stages, project concept, initiation, planning, mobilization, execution, control monitoring, and completion. SMS and IRT created the project concept. I touched on the concept beginning of the presentation. In the initiation stage, the participants worked out the business case, investigated the funding option, established the project goals, and recruited the consortium partners. In the planning stage, Aberdeen shared the shortlisted properties for the project, also established a communication channel with the residents about the project requirements, aim, and level of disruption. SMS worked out the solution, design specification, and general design. SMS evaluated the potential assets and selected the assets which fit to the project. Then Robertsons worked out the project plan, which included all fabric retrofit works and technology installation, and made good tasks. In the mobilization stage, the partners carried out energy and structural surveys in the properties. Based on the survey reports, SMS shortlisted the properties which can receive the technology. And the selected solution was finalized according to the selected properties. In the execution stage is where the project is at the moment. The installation and fabric upgrades are ongoing. Now 2 properties is completed. The heat pump, PV, and battery system works as they should. The control and monitoring stage will focus on the installation witnessing procedure, handover to the client and the residents, soft landing services, and intermittent maintenance before and after the heating season, support the residents, and verification of the system operation and benefits. And the last stage is the completion, where the consortium will close the project, create a project closure study, and highlight the future opportunities and replicability of the project. Aberdeen City Council released circa 120 sites for the project. These properties were 1-bedroom bungalows, mid and end terrace houses, and semis. A quarter of the houses were suitable to receive the technology upgrade. The proposed technology solution was only fine-tuned to the final quarter of the properties. Challenges. The team discovered the following challenges. Needed to find the right properties with the right energy consumption. Typically, 1-bedroom bungalows have low heating and electricity consumption. That's why these properties were not suitable to receive the technology. The product fits to serve 2 to 4 bedroom properties with a higher amount of energy consumption and can utilize the benefits of the PV battery assets and utilize the heat pump benefits. Orientation and shading are crucial factor in PV design. Free space needed to find enough space to locate the heat pump and the battery safely and keep all the manufacturer clearances. And the houses had to have a space where the hot water cylinder can be positioned with the minimal disruption possible. And lastly, the residents had to opt into the project. Project status. As I mentioned, 2 properties are completed. These properties will require new metering arrangement and some minor modifications, which were discovered on the witnessing survey. PV arrays are mostly installed. The contractor is waiting for the DNO to complete the necessary unlooping and power upgrade works. And the challenges via the project. In the last 2 years, the project suffered from a couple of significant challenges. The COVID-19 required increased safety measures, reduce virus spreading, and protect the residents and our contractors' workforce. The pandemic and the supply chain transformation had a significant impact on the lead times. The suppliers changed estimation lead times almost weekly, and at some point they could not be able to give an estimated lead time at all. Nowadays, these lead times are mostly normalized. The electrical designer found out that most of the properties have loop supply. The loop supply means 2 or more property have one incoming power supply, and these properties are connected to this cable in line. That's why the DNO have to carry out unlooping works, which can take up to 6 to 9 months. The increased inflation, supply chain, number of design iterations, and management time also had an impact on the project progress. And lastly, the small number of properties caused difficulties with the return of investment calculations. On my last slide, I'm presenting to you the benefits of the project and some challenges future projects could consider planning ahead. Our team focused on minimizing the modification and disruption in the properties. The presented product can be suitable to retrofit or new build dwellings. We believe this is the right step to reduce the carbon emission. The product and the fabric upgrade can provide visible benefits to the residents. In some cases, the technology can be useful without fabric upgrades. For example, if the property is built by a higher insulation standard, the owner of the product could discover grid services revenue stream and an export agreement with one of the energy suppliers and can generate an export revenue to reduce the payback period. And finally, the contractor chain could be reduced. Any future project could consider lead times and DNO works and plan ahead. My opinion is this is a great R&D project. The team discovered and solved many challenges and problems. The installations are going and we can see the light at the end of the tunnel. Thank you very much.